Hello, hello. Hello, hello. Okay, maybe everything is working, but really bad. Really terrible. Hello, hello. Hello, hello. Hello, hello. It says we are streaming, so I don't know. I don't know. Python try and accept our ways of testing our code. Where did we stop last time? Here? Else? Oi. Fuck. Turns out there's another way to implement try and could catch error of this nature. Adjust your code as follows. Notice that if no exception occurs, it will then run a block call within else, running Python number pi and supplying 50. So instead of writing this inside of try, you can have it in an else statement, which will change it, which will make it so that when the code runs, it will first try this. If no error, it will skip this and write this. Okay, seems good enough. Notice it will then run on the block of code within else. Run in Python, supplying 50. You'll notice the result will be printed. Trying again. This time supplying cat. You notice the program now catch there. Considering improving code, notice that we are being able a bit rude to the user. If our user does not cooperate, we currently end our problem. Consider how we could write, how we can use a loop to prompt the user for X, and if they don't prompt again. Notice the while true will loop forever. If the user succeeds in supplying the correct input, we can break from the loop and then print the output. Now, a user that inputs something incorrectly will be asked for input again. Aha. So basically what's happening is uh, when we try, we write a while loop, we we try this statement. If the statement wrong, it will print this error. If it's true, it will break, it will stop, and it will print the result. So only if it's true, it will break and print out. Mm-hmm. Okay, that makes sense. Hold on. Why is my my YouTube is in Russian? Hello. Never mind. I think it's fine. 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 Beep 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 beep. Yeah, the business. Beep 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 beep. Who's making noise? Yeah, the business. Yeah, the business, brother. I don't want this to be here. There we go. That's good. I have to check the stream multiple times. 1, 2, 3, 1, 2, 3, 1, 2, 3, just to make sure everything is running perfectly. Can I refresh this? No. I don't know. Anyways, let's continue. Created a function to get an integer. Surely there are many times that we would want to get an integer from our user. Modify the code as follows. So, okay. Mm-hmm. Number 3. Oh, fuck's sake. Some typing. Mm-hmm. Number 3. Sure, there are many times that we would like to get an integer. Define main. Notice that we are manifesting many great properties. First, we have abstracted away the ability to get an integer. Now the program boils down to the first 3 lines of the program. By number 3. Wait, we need to enter lesson 3. cd lesson 3. And now we try to run the code. Number 3. Number 3.py. What am I doing? Py number 3.py. Okay. 1. X is 1. We can surely turn the tide. We can push the tempest wide. Let's write the code. Def main input def main input what? Oh, so we used x get int to get the integer from here. Interesting. Very interesting. So x will get int print f def get int. Get int. Just use the. I thought this is a function. We just use this get int in this not class but function. I thought this is a function by itself, but we're just creating a function here to use it. Now we should have music on YouTube. Do we have music on YouTube? Do we have music on YouTube? Yes, we do. Okay, we have music on YouTube. Whatever. Let's continue learning. Clean. Learn programming with me. Learn programming with me. With me. Let's change it again. Yep. Okay, perfect. Okay, let's continue, baby. So we write a function. While this function is true, we want it first get the input of from the user. So we write input. The music is a bit loud. Okay, music's fine. First, we get the input. No, we forgot try. Okay, try. Try. We try. Try x equal integer. Sorry, I'm trying to remember stuff because I have it programmed for a while. What's x? We add a space here, so when we ask the question, it won't be stuck to the sentence. So try except, right? Except value error. So value error means this value has an error, so it will check if this value of x is an input or not, because we use the int here. So if it's not input, it will print x is not an integer. And else, if the value is correct, we break it, and then we type return x. And we don't forget about our main. What is it? What is this called? What is main at the end of code called? We call this a direct call. Okay, so it's a direct call from here to here. Perfect. Okay, so I basically kind of understand how this works, so I think we can continue from here. Notice that we are manifesting with great properties. First, we have abstracted away the ability to get an integer. Now this whole program boils down to the first 3 lines of code. Even still, we can improve this code. Consider what else you can improve. Modify your code as follows. Return x. So else, return x. So return x. It can act as a breaker and also a return function. So it will get back the result from here back to here. No, it will get back the result from here back to here. No, it will get back the result back from here to here and then here. Excellent. Notice that return will not only break you out of loop, but some people may argue you could do the following.
Will you go down to the station and get me a ticket on the 11 o'clock?
Fewer lines. So we don't use it at all. Oops. Create another one. 4. Okay. Let's try to run it. 4. What's x? Okay, x is not inch. 1. X is 1. Okay, perfect. It works. Yeah.
Just excited.
Now we move on to pass. What is pass? We can make it such that our code does not warn the user, but simply re-asks them our prompt in question by modifying our code as follows. So basically, should call should probably rename these. Yeah, I'll rename it try 0, and then try 1. And these things are using else. Try with else. I don't like that. Looks ridiculous. Try with else. Yeah, you can call it that. Rename. Try with else 1. Name. Try with else 2. What is this? Why do I have a copy? Try with else 3. Yeah, this is good. Okay. Get new file. I'll call pass 0.py. Now then, we make it such it does not warn us, but instead pass will get us back the first code. Okay. Diff main. Diff main. Let's create our function first, then we'll connect it to diff main. Diff get. Where's my botrix in Russian? I don't understand. Anyway, get the integer. Def get int while true. Try return. Oh, I see. I made a mistake somewhere. Oh yeah, because it was using return here. It will return. Okay, I did not make any mistake. Instead of user return, we just immediately use return it. So yeah, technically it makes the code smaller. Let's see. Return int input what's x. What's x? Set value error pass. Mm. Let's see. It's equal get int, and then we'll print f. Calm down. F x is x. Now let's try to run it. Pi plus dot pi. Pass 0 dot pi 2. This is 2. Perfect. So basically what happened here is created main. Before we create these, we will create our function. So while true, we'll create a loop. So while this loop is true, we'll try first this return integer input plus x. Expect value pass. So what does pass do? It will skip the value error, I think. No. Notice that our code will still function, but will not repeatedly inform the user of their error. In some cases, you'll want to be very clear that the user what error is being produced. Other times, you might decide you simply want to ask them for input again. So. But then we don't have anything for pass. So let's try this. Okay, we'll break. Okay. X is not integer. X is not integer. What? Shouldn't it tell me like once? What if I do break? Break will break it, right? X is none. Interesting. So instead of printing out an error, it printed out X is none. I mean, instead of just breaking out of the code, it actually printed something. Interesting. More refinement that can improve the implementation of this getIn function right now. Notice that we are relying currently upon the owner system, that the X is both the main and get function. Probably want to pass it in a prompt that the user sees when asked for input. Modify your code as follows. What's the difference between this and this? Mm. Prompt. Pass. Oh. What you talking about? Oh, I like it. Actually, let's just keep it versions. Not versions, versions. Oh, prompt. Prompt. What's X? That's interesting. So we can write it this way as well. So what's X? 1? Interesting. So basically what's this showing us? There are many ways you can write same function, the same thing. Yeah. Yeah. So basically what we did, get int, what's X? So this is what is called prompt. Get int prompt. So we call the thing prompt. So the prompt will take this and assign it to prompt. So input prompt. Okay. Oh, that's it for exceptions. That's short tutorial. Okay, let's go and watch videos now.
Or might surely in the future.
Kind of hungry, so I'll go get something.
is now completely rewound, ready for playing.
Good shit.
make, and it's a little subtle because you might not necessarily notice that you've just missed that one character. Well, let me go ahead and somewhat optimistically go down to my terminal window now and run python of hello.py and hit enter. And that's the first of my errors. My gosh, I've only written one line of code, and I seem to have more lines of errors on the screen. But the salient point is this bottommost thing here. Notice where it says syntax error. A syntax error is a problem with the code that you have typed, your syntax. Just like English and other human languages have syntax associated with them, so does my code. And it's not quite correct. Something is awry. I didn't follow the instructions properly. And it does elaborate for me, unterminated string literal. Now, that's a bit arcane. That is a bit of a confusing error message. But unterminated would generally mean that I started something but didn't stop it. I didn't terminate it. String, of course, is a sequence of text like we discussed before, or str in Python. And literal generally refers to something that you literally typed. It's not a variable. It's something like quote unquote, or just quote, hello world. So the fix here, of course, is going to be to go ahead and terminate that string and actually close the quote. And if I now go back down into my terminal window and rerun python of hello.py, now I'm saying hello to the world. So the catch with syntax errors here is that syntax errors are entirely on you to solve. A syntax error is a problem that you've got to go back into your code and fix from the get-go. You can't just kind of hope that it's going to resolve itself or expect that other parts of your code will catch it for you. Syntax errors just must be fixed. But there's a lot of other types of errors in Python that might be described as runtime errors that happen while your code is running, and it's really up to you to write some additional code defensively to detect when those errors happen, because you don't necessarily know, for instance, what input humans are going to type into your program, and so you better be ready defensively to accommodate things that they type or even mistype. So for instance, let's go back over here to VS Code, and let me propose that we take a look at a new file altogether. I'm going to close hello.py, and I'm going to write code of, say, number.py. So let's play around with some numbers in Python. And the first thing I'm going to go ahead here and do with number.py, after opening this new tab, is I think I'm going to go ahead and type up a relatively simple program that maybe prompts the user for an integer, like x, and then just prints out what x is. So we're going to start super simple, but again, in starting simple, we'll be able to really see where I've done something wrong. Well, here we go. I'm going to go ahead and say a variable called x is going to get assigned the value of the return value of input, quote unquote, what's x question mark, and I'm going to include a space to move the cursor over a little bit, and then ultimately I'm going to go ahead and, oh wait a minute, if I'm wanting to get an int from the user, recall that I need to do something proactively. I need to actually convert that input to an integer using the int function in Python. So now I'm passing the return value of input as the argument to int, and that will store in x ultimately an integer, not a string that looks like an integer. All right, let me go ahead now and just quite simply print out what this is. I'm going to go ahead and print out quote unquote x is x. But I don't want to literally say x is x. I want to plug in the value of x. So maybe the easiest way to do that is to surround it with curly braces.
Demon. He's fucking woo. Oh.
And then if I'm using these curly braces and I want Python to interpolate the value of that variable, that is, substitute what x actually is in between those curly braces, recall that I need to use a format string or an f string by prefixing this whole thing with an f. Now that I've done that, let's go ahead and see what happens. I'm going to go ahead in my terminal window and run python of number.py. I hit enter, and so far so good. All is well. I'm being prompted for x. Let me go ahead and type in a number like 50. All right, that seems to work. Program seems to be correct. Or is it?
Or is it?
What could go wrong in this program, even though nothing did just go wrong? But if I run it and run it and run it again, during the running of my program, what could still go wrong? Especially if I'm not the human interacting with it, but some other human instead. Any volunteers here for this one? What could go wrong? And in what way is this program not really correct, even though at first glance it seems so?
What is an interpreter? So, when we code in a integrated IDE, we can't code in an interpreter.
So I'm not calling an integer. I'm still having trouble hearing you, but what I think I heard is that if what the user types in is not in fact an integer, I can't just
Didn't
blindly
understand
convert
anything
it
he said.
to an int. If I'm not putting too many words into your mouth, I think what I should perhaps do here is be a little defensive, and let me see if I can't simulate exactly the problem that could go wrong here. Let me go ahead and run, again, python of number.py. Let me try another number. In fact, when testing your code, generally it's a good idea to test corner cases, maybe numbers that aren't quite as plain as 50 or 49 or 51. Let's choose some numbers that might be a little more interesting, if only mathematically, like 0. All right, 0 seems to work. My code still prints out that x is 0. What might be another corner case to consider? Well, let me go ahead and try a negative number. That, too, is pretty different in spirit from 50. Negative 1? OK, that works, too. Well, let me try it one more time. I've tried positive numbers, negative numbers, 0. Let me try something like a cat. So literally, C-A-T, typing in a string that doesn't even look like a number. And yet, let's see now what happens when I hit enter. All right. We'll see now we've got another kind of error. It's not a syntax error because I didn't make a typographical mistake. I didn't forget some piece of syntax. I actually now have an error with one of my values, and it's in a value I didn't even anticipate. The human, me in this case, typed it in long after I wrote the code. So what does this refer to? A value error. Well, let's see what the explanation is. Invalid literal for int with base 10, quote unquote, cat. Now, this, too, is a bit of a mouthful. And unfortunately, in Python and a lot of programming languages, the error messages are written for pretty comfortable programmers. And of course, when you're learning programming for the first time, you might not be so comfortable with the programming language, let alone the error messages. But let's see if we can't glean some insight. So invalid literal. Well, again, a literal is just something that's been typed in, it would seem, for int. What is int exactly? Well, int is the function I'm using to convert the user's input to a corresponding integer. Base 10 that refers to the decimal system, which is the default that Python's using. And it looks like, at the end of the day, what Python really doesn't like is that I passed cat, quote unquote, to the int function. So how do I go about actually fixing this problem? Well, I could just add instructions in my program. Maybe I could add a line of print telling the user more explicitly, be sure to type an integer. Or please don't type cat. Please don't type strings. Of course, the user might still not oblige. They might not be reading the instructions. So that, too, is probably not an effective strategy. What we really want to do is write our code with error handling in mind. We want to write lines of code that not only accomplish the problems we care about, but that also handle errors that might unexpectedly happen. And in general, when programming defensively, assume that the users aren't going to be paying attention, or worse, they're malicious. They're trying to crash your program, so we want to handle as many errors as we can. Now, how do we go about doing that in Python? Well, it turns out whether you want to catch a value error or other types of errors as well, though not syntax error, Python actually has this keyword called try, and it's sort of aptly named. If you want to try to do something in Python, you can literally use this keyword, and you can check whether or not something exceptional, something erroneous has happened. So using both try and this other keyword except, can I go and try to do something, except if something goes wrong, I can do something else instead. So let's consider, how can I go about trying to convert the user's input to an int, except if something goes wrong? Well, let me go back to my code here, and let me propose that I now modify this example as follows. Let me go ahead and above my first line of code, I literally write try and a colon, telling Python, try to do the following. I'm going to go ahead and indent my existing lines of codes here by the same number of spaces, 4 in this case. And then I'm going to add one more new line down here that literally says except value error. And notice it's important that I've capitalized the V and I've capitalized the E. These symbols are case sensitive. And this is now an opportunity, after this colon, to tell Python what I want to do in exceptional cases, when the number or the input from the user is not, in fact, a number. And I'm going to say something plain like print, quote unquote, x is not an integer. I'm at least going to tell the user roughly what the problem actually is. So notice another detail. The indentation is important. Because I have try on line 1 and I've indented lines 2 and 3, those are the 2 lines of code that I'm trying. Except if I see a value error, line 5, because it's indented, is what is going to get executed in cases of those errors. Let me go ahead now back to my terminal window and run Python of number.py, enter, and let's go ahead and type in 50 again. Still seems to work, and of course I'm trying and succeeding. Let me go ahead and try once more, this time though with the word cat, or really anything that's not a decimal number, and now you'll see much more cleanly x is not an integer. I'm not seeing some scary error message that I, as a user, am going to have no idea how to handle. Now you, the programmer, have anticipated that something exceptional can happen, and you've gone about actually handling the error for the user, giving them an appropriate error message instead. Let me pause here and see, are there any questions now on what we've just done by introducing try and except to handle this value error?
Is value error the only type of error you can get, or are there other types?
Is value error the only thing you can catch? There are other errors as well, and we'll see a few of them today. And there's many, many more, honestly, that if you continue programming in Python, you're going to see a lot of them over the weeks, the months, the years to come. But the technique for handling them is going to be largely the same. Other questions on try, except, or these exceptions more generally?
Yes. Sir, actually, to use the except block, you need to know the type of error, right? Like here you knew it was a value error. What if you can't anticipate this particular type of the error?
A really good question. So I'm being very good about catching, so to speak, the very error that I know might happen. I don't know when it might happen, because it's going to depend on the user, but I know what kind of error will happen from the int function. There is a way in Python where you can say except if anything goes wrong, and you can literally omit value error and just catch everything. The problem with that is that it sometimes hides other bugs in your code because you don't necessarily know what's going wrong. And if you don't necessarily know what's going wrong, how can you possibly handle it correctly? So bad practice. And put another way, it's lazy to do that, to just say catch everything and I'll deal with it here. So a much better practice would be to figure out what kind of errors could happen and include mention of them explicitly as I've done. Now, with that said, if you read Python's official documentation, as you'll eventually invariably do, it is not great about telling you proactively what kinds of errors can be raised in this way. So it's a bit of contradictory advice. You should do it this way, but it's not always obvious what you should be checking for. But you get better at it with practice. And some of the times the documentation does spell out what could go wrong. Let me turn our attention now back to this and point out that even though this is better code, it is more correct in the sense that I'm not just leaving it to the user to see some really ugly default Python error message that most people are going to have no idea what to do with. I'm at least handling it more elegantly, and I'm printing out x is not an integer. So it's at least more instructive. But this isn't necessarily the best way to implement this code. Why? Well, here too, I'm actually still being a little lazy. So notice that I'm trying to do not one line of code, but 2 lines of code. And this isn't a huge deal, because we're only talking about 2 lines of code. But in the interest of preaching best practices, you should really only be trying to do the one or very few lines of code that can actually raise an exception, that can actually fail in some way. I am pretty sure that calling print here is not going to raise a value error. Whether x is an int or a string or a float or anything else, the format string feature of Python is going to handle printing it just fine. So really what I'm going to do is this. I'm going to move this line 3 down to the bottom of my code. I no longer need to indent it. I'm just going to execute it at the bottom of my file here. Unfortunately, by doing this, I've done a good thing by now only trying to do the minimal amount of work necessary that might raise the exception, a value error, but I fear I've introduced a new mistake. Well, let's see. What is now incorrect? Let me go ahead and again run Python of number.py, enter. Let me go ahead and do it correctly with 50, and all seems to be well. But again, let's try those corner cases, the zeros, the negative numbers, or in this case, the cat. Let me go ahead and type in CAT again, enter. Now I have a name error. So now it's yet another type of error in my code that I've introduced here. And what does this name error mean? Well, just as a value error refers to that, the value of some variable, the value that someone has typed in is incorrect, name error tends to refer to your code. Like you're doing something with the name of a variable that you shouldn't. And why might that be? Well, let me turn our attention back to the code here and consider, what is it complaining about? Well, the name error is what I see down here, and it's telling me name, quote unquote, x is not defined. And notice if I look further here, it is mentioning line 6. So I know the problem is with my code on line 6. And that worked a moment ago, and I'm defining x on line 2. But let me ask the group here, why does x not in fact exist on line 6? Why is it not defined, even though I'm pretty sure I was intending to define it on line 2?
Maybe the scope of the variable is between the try block.
So good terminology. Scope refers to the portion of code in which a variable exists. That too, though, isn't quite right in Python. That would be true in C, C++, and Java, where indentation or curly braces tend to define the scope of a variable. But again, here in general, and this worked a moment ago, x exists once it's defined on line 2, because remember, I printed out x is 50 a little bit ago. Let's try one more hypothesis here. One more hand. Why is x somehow still not defined?
Yeah, so is it because it's local variable, meaning that like it doesn't define outside of the scope, because like what people have mentioned, it prompts the input in try, right? But outside of it, it's not defined.
So still good instincts and good terminology too. There's this notion of local variables, which tend to exist inside of functions, for instance, global variables, which tend to exist in entire files. In this case too, though, that's not quite the case. What's happening here boils down to order of operations. Let me come back to the code here and recall that anytime we've discussed the assignment operator, the single equal sign, that copies a value from the right to the left. But consider for a moment at what point something is going wrong. Well, the input function is probably working just fine, because we've used that a lot now to get users' input. It always returns a string or a str in Python. But what could be going wrong? Well, if I'm passing that string to the int function as its argument, it's probably the int function that's erroring. And indeed, if you think back earlier when we had the value error, it was in fact the int function that did not like quote unquote cat as input. So this is all to say that this portion of my code, highlighted now to the right of the equal sign, that's the code that's creating a problem. That's the code that was creating a value error. And in this case, we're catching the value error. But because the value error is happening on the right of the equal sign, there's no value being copied to the left. The error is interrupting that whole process. So even though we see x equals ... on line 2, the portion of that line to the left of the equal sign isn't getting evaluated ultimately, because the value error is happening too soon. And so when we finally get down to line 6, even though it looked like I was defining on line 2, and I would have defined x on line 2 if all had gone well, we didn't get to the part where the value is copied from right to left because the value error happened first. So this code is just incorrect now. So how do I go about solving something like this? Well, it turns out that there's another feature of the try and except syntax that Python supports, which is that it also supports the keyword else. Now, we've seen else before. If you think back to our discussion of conditionals, we saw if, we saw elif, we saw else, which was kind of this catch-all, what you should do in the event that nothing else is relevant. That's kind of the same intuition here for the try except feature of Python. What you can do is this. You can try to do the following, as I've done, except if this goes wrong. But if nothing goes wrong, else go ahead and do this. So this is one way I can solve this same problem now. No matter what now, Python is going to try to execute line 2. If something goes wrong, it's going to execute lines 3 and 4 to handle that value error. However, if you try and this code succeeds, then there is no exception to handle, so you're then going to execute this line here. So it's a little confusing perhaps in that we're now using else both for conditionals, if, elif, else, and we're also using else with these try except blocks, but that's okay. That's part of the language. That's one of the features. So now if I rerun this code in my terminal window, Python of number.py, let's do something correct, like 50, I see that x is 50. So line 1 is executed. We're trying to do the following. Line 2 is executed because the conversion happened successfully and the number 50 gets copied from right to left. The exception does not happen, so we ignore lines 3 and 4. We jump immediately to line 5 and 6, which prints out the result. By contrast, though, let's do this one last time. Python of number.py, let's type in cat, or again, any other word, and hit enter now. We don't see what x is. Rather, we see, quote unquote, x is not an integer, which is what's being handled in my except clause. All right, let me pause here, because that's a lot of new syntax, and see here if there's any questions on try, on except, on else, name error, or value error.
Can you please repeat try function?
Repeat the name error. What's the problem with the name error?
Yes.
Yeah, so let's just rewind a couple of lines here before I fix this problem by now getting rid of the else. A moment ago, we had code that looked like this, whereby I was getting a name error, Python of number.py, enter, typing in cat. Feedback, but notice again I'm prompted, what's x? Well, let me try typing in dog. X is not an integer. What's x? Let me try bird. Enter. X is not an integer. What's x? And suffice it to say, this will happen now forever if I'm in an infinite loop until I try and succeed, at which point I break out. So let's try again. 50, enter. Now I'm out of the loop, and I'm printing out what x actually is. All right, let me pause here and see if there are any questions. The logic is almost the same, but what is different now is I'm in a loop, and I'm using the keyword break in Python to deliberately break out of the loop when I'm ready to, once the user has cooperated.
Do we really need to break? Can't we just print? Or what keeps us from just printing?
Good question. So let me try that. Couldn't I just print? Well, let's see what happens if I do that. Let me move this print line at the end into my loop here, thereby shortening the program. And in general, that's been a good thing. Python of number.py, enter. Let me go ahead and type in 50. OK, x is 50. What's x? OK, maybe it's 49. X is 49. OK, maybe 48. Unfortunately, I think you're laughing. You see it. I never break out of the loop, which maybe that's a feature. Maybe you want this to be your program, but I didn't. I'd eventually like this game to stop, so I need to break out in that way. But I can do it a little differently, and let me propose that we modify this a little bit. But first, any other questions on this syntax here? Let me rewind to the prior version.
Hi, can I use break or in exception, except in else? For example, in another print, when you use print in the else, you can use print together with break or something like this?
So you can use break inside of loops to break out of loops. And you can use it inside of a conditional, like an if, an elif, or an else. You can do it inside of a try, except, else statement too. Anytime you're in a loop that you want to break out of, you can use this keyword break. I'm using it in the context of exceptions, but it's not restricted to that. And let me show you too, it doesn't even have to be in the else. If I wanted to, I could actually do this. I could get rid of my else, and I could go back to line 3, add another line that's indented, line 4, and break out here. Now, why is this logically OK? Well, consider what I'm now trying to do. I'm trying to execute line 3 and converting the user's input to an int, and I'm trying to store the result from right to left in x. If something goes wrong, the code we've already seen is immediately going to jump to line 5 and then 6 to handle the exception. But if nothing goes wrong, my code presumably should just keep on executing line by line. So I could technically, logically put the break here and watch what happens when I run this version. Python of number.py 50 enter. It worked. I broke out of the loop. Now, which way is better? Honestly, I think it could go either way at this point. This program's so relatively short that even though I'm trying to do two things now, one of which, the break, is not going to fail. Like, you either break or you don't. There's no piece of data from the user that's going to influence that. We don't strictly need to have those 2 lines of code there, but it's only 2 lines, so I think it's OK. And if you recall our discussion in the past, not just of correctness, does the code work as it should, but design, I think you could argue it either way. If you prefer the readability of this and the fact that you don't have an else, that's fine. If, though, you prefer to minimize just how many lines of code you're trying to execute in case something goes wrong, the else is a reasonable approach too. Well, allow me to propose too now that we refine this further. I think we're at the point where it's pretty darn correct. But suppose now that I find myself today and tomorrow trying to get numbers from the user quite a bit. It would be nice, as we've seen, to maybe just invent my own function, getInt, to get an integer from the user both today and tomorrow and beyond. And heck, maybe I can even share that function with other people if they want to write programs that get integers from users. So how might I go about doing this? Well, let me go ahead and propose that we do this. Let me get rid of the print line, but keep most of my loop here. Let me define a function called getInt that takes no arguments for now. And I'm going to go ahead and indent all of the code I already wrote underneath getInt. So now I have a function called getInt that tries to do the following. Try to get an int from the user. If something goes wrong and there's a value error, yell at them with x is not an integer, else break. But it's not just breaking that I want to do here. Now that I'm in a function, recall our discussion of return values. If you're inventing your own function whose purpose in life isn't just to print something on the screen like a side effect, but is to hand back a value, to hand you back a value, like on that same post-it note from our discussion of functions, well, you need to return x explicitly. How do I now use this function? Well, as soon as we start making our own functions, it tends to be convenient to define our own main function as well. That's the main part of our program. And I'm going to keep this simple. I'm now going to say x equals getInt. And then on the next line, I'm going to do that print from before, quote unquote, x is, in curly braces, x. And at the very bottom of my program, recall, I'm going to call main, so that no matter what, I'm invoking my main function after everything's been defined. Well, let's see how this works. Let me go ahead and run Python of number.py, enter. Let's type in 50, and it seems to work as before. Let's go ahead and run it again, typing in cat, C-A-T this time. X is not an integer, and I'm being prompted. Dog, and I'm being prompted. Bird, and I'm being prompted. Fine, 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 50. That's an int, and so it is printed. So what's worth noting here, well, I'm manifesting a couple of good properties here. One, I've kind of abstracted away this notion of getting an integer. And even though I just artificially hit enter a whole bunch of times just to hide that function for now, it needs to be there, but we don't need to see it at this point. Notice that now this entire program really boils down to just these 3 lines of code now. Why? Because I've abstracted away that whole process of getting an int from the user into this new function of my own called getInt. But can I improve upon this? Well, let me go ahead and undo all of those blank lines and pull this up just so we can see more on the screen at once. Can I tighten up my implementation of getInt? It is correct. I claim this is correct. It's handling errors and it's returning x, but I don't, strictly speaking, need to write the code as long. What else could I do? Well, let me propose that if all you're doing on this line 13 is breaking, and then immediately after that, per the indentation, you're executing return x on line 14, why are you wasting everyone's time? Once you know you're ready to return the value, you could just return x. And so in my else, I could break out and return a value. So here too, return is used to return values from functions. Break is used to break out of loops. But it turns out that return is sort of stronger than break. It will not only break you out of a loop, it will also return a value for you. So it's doing 2 things for once, if you will. But can I make this even more compact? If my goal is to just tighten the code up, even though it's already correct, can anyone think of a further refinement, whether you've programmed in Python before or not? Can I shorten this implementation further, just a little bit, if only to decrease the probability that I've made a mistake by having fewer lines, and just make it a little easier to read because it's shorter? Any suggestions for tightening up my implementation of getInt?
You can just return the value on the try function when you're trying. You take the input x and then return x.
Good. We can just return x a little higher up. And let me correct folks as we go. It's not a try function. It would be a try statement, technically. A function typically has a parenthesis and another one. In this case, it's just a statement. But we can do exactly that. I don't technically need the else. If I really want, I could do this. Right after line 9, I could return x here. Or recall our discussion of defining variables unnecessarily sometimes. Like, why define a variable here if you're immediately going to use it here and then never again? So we could avoid a new line here. And I could avoid even defining x explicitly. I could just say something like this. I could return int input, quote unquote, what's x. I can do it all at once. Now, which is better? I don't know. I mean, again, this is where reasonable people might disagree. I'd argue that on the one hand, we're tightening up the code. We're using fewer lines. It's easier to read, lower probability that I've made a mistake. On the other hand, it's a little more complicated to understand, perhaps. It's a little less obvious where I'm returning from. So I think arguments can be made either way. At the end of the day, what's important is that you've done this consciously. You've made a decision to do it this way or this way, and you can justify it in your mind, not that your answer is, it worked, so I left it alone. Like, have a good reason. Come up with a good reason, and that will come with experience and practice. Well, let me propose, too, that we make one other refinement here. Suppose that you're finding your programs to be a little noisy, and it's a little obnoxious that you keep telling the user x is not an integer, x is not an integer, x is not an integer. What if you want to make things a little gentler and just prompt the user again with the same words, what's x, what is x, what's x, again and again? Well, you can do that as well. And it turns out that if you want to handle an exception in Python, but you want to pass on doing anything with it, so you want to catch it, but you essentially want to ignore it. You don't want to print anything. You don't want to quit the program. You just want to silently ignore it, like if you're talking in a room full of people and it's your turn to talk and you're just like, pass. They're still calling on you, but you're not doing or saying anything more. Well, we can add this keyword to our code here. Let me go back to my program here. And instead of printing out again and again, x is not an integer, I could just do this. I could pass on handling the error further. I'm still catching it, so the user's not going to see a scary message even mentioning value error. My code is catching it, but I'm passing on saying anything about it. I'm going to stay in the loop. I'm going to stay in the loop and keep prompting and reprompting the user. So now the effect looks a little something like this. Python of number.py. Let's type in cat. What's x again? Let's type in dog. What's X again? Type in bird. So it's just a little, maybe more user-friendly in that you're just reminding the user what you want. Maybe it's worse. Maybe it would be helpful to tell the user why you're prompting them again and again. It's not obvious, so it could go both ways. But again, it's just another mechanism now for handling these errors. We use the accept keyword to catch a specific error, but we don't have to handle it more than that. We can just pass on doing something further. Let me pause here and see if there's any questions now on try, accept, else, or pass.
Okay, yeah, no, I was just kind of curious, I guess, about the idea of when you were indenting with the getInt function, for example. Because I'm noticing, you know, obviously going through it with the whole logic and breakdown of the entire function, you know, while true, do this. But I'm just kind of curious on elaborating with the indentations for the code more.
Yeah, so the indentation is deliberate logically. Some languages don't require as rigorous indentation. You can use curly braces or other symbology to make clear what is associated with what. In general, anytime you indent something in Python on this line, anytime you write a line of code in Python that's here, and the lines below it are somehow indented, that means that those lines are somehow associated with that first line. And presumably, those indented lines should only be executed if the first line told the computer to do so. So concretely, what does this mean? On line 6 here, we're defining a function called getInt that takes no arguments, colon. Everything that's indented by at least 4 spaces hereafter is part of that function. Why? That's just the design of the Python language. Frankly, I think the designers got tired of seeing really ugly code in languages like C and C++ and Java that don't necessarily enforce indentation to this extent. So now it's baked into the language. And my chronology might be a little off there, but there's been many languages that are looser than Python when it comes to indentation. The indentation is meaningful on line 7 too. Notice that because the while true is indented by 4 spaces, that just means it's part of the getInt function. But notice below the while true statement, there's 8, there's 12, there's 8, there's 12 spaces here, and I'm just quickly counting the dots. That means that all of the lines I've just highlighted are inside of that while loop. While true means to execute lines 8 through 11 potentially.
Another way of saying this, basically, even when you press tab, it's probably 4 spaces. Tab is how many spaces? Isn't it 4? 4 space, yeah.
Again and again and again. And now
So it's easy
lastly,
there this way.
on line 8, because we have try and indented below it is line 9, that just means that what you should try is what's on line 9. And similarly, on line 10, below it, we have indented line 11. You should only pass when there is an exception of a value error. So the indentation just means what is associated with what. And once you get comfortable with that, you'll see that it helps, the indentation alone helps explain the logic of your program. And it has a wonderful side effect that for yourself the next morning, for your colleagues, your family, your friends, your teachers, your code is much more readable as a result. It's not one big mess of a blob of text. Other questions now on try, accept, else, or pass?
Yeah, thanks. Two questions. Question one, once you say pass, can the caller still learn anything about this error through a system variable or whatever? And question two, problem set 0 referenced some string methods, including is numeric. Is it any different to go via is numeric here?
A good question. So on the first question, if I'm handling the error in this way, the caller's not going to know anything about it. That's the point of my handling it, so that main or other callers don't know that anything technically went wrong. On the second question, is numeric is another function that you can call that can look at a string and determine, is this in fact a number? I could use a mechanism like that. I could use a conditional. If this looks like a number, then pass it to the int function and go ahead and convert it to an integer. That's totally fine. I would generally say that the Pythonic way of doing things is often, for better or for worse, to try things, hope they work, but if they don't, handle the exception. So other languages are more in favor of checking if, elif, else, and all of these conditionals. Python tends to be a little more of the mindset, try it, but just make sure you're handling the error. So this would be the Pythonic way of doing it. Your way, though, checking with a conditional, is it a number first, is totally reasonable too. if you want to go that way. Well, let me propose some final refinements to the variables and put whatever prompt.
Okay, debugging.
All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is a look at debugging. Odds are by now you've written quite a bit of code, and within that code is at least one, maybe even more bugs. That is, mistakes that you accidentally introduced to your code. Now, maybe your code doesn't even run at all and you have some form of syntax error, or maybe you've gotten past that hurdle and you just have one or more logical bugs, so to speak, whereby when you run your code, it doesn't produce the output that you actually intended. So it's not quite correct. There are mistakes therein. And how do you go about then solving those problems? Well, if you can't quite wrap your mind around what's going wrong by just reading with your own human eyes your own code from top to bottom, left to right, and you don't have, for instance, a teacher, a friend, a colleague, a rubber duck to help you reason through what might be wrong in your code, what kind of tools do we actually have for chasing down bugs in code and ultimately fixing them? Well, already we actually have some tools at our disposal. And for instance, let me propose that we build something like this in code. So pictured here is Mario from Super Mario Brothers, the original Nintendo game, jumping over a pyramid of sorts. And that pyramid is implemented with these bricks of sorts. Let's go ahead and create a textual version thereof, whereby we use maybe hash symbols, simple hashes, to represent each of these bricks. And therefore, the goal in printing out a pyramid textually that resembles that of Mario here would be to print out one hash, and then two hashes, and then three hashes, and perhaps more if the pyramid itself is higher. Well, let me propose that if I open up VS Code here, and in advance I've created a file called mario.py, let me propose that this is my intended solution to this problem. Let's go ahead and walk through what's here. I first, at the top of my file, have a main function defined, inside of which is a second line of code that calls input, asking the user for the height of this pyramid. Immediately, the return value of input is passed to the input of int, so as to convert that textual input, presumably, to the corresponding integer. And then I'm storing on the left-hand side of that equal sign the value that the user typed in, be it 1, 2, 3, or anything else. And then I'm using that variable as an input to a function that's apparently called pyramid, so that I can ultimately print out a pyramid of that height. All right, well, what is this pyramid function? Well, it looks like on this line 6 that the pyramid function expects one argument called n presumably for number. And how am I using that number? Well, inside of this function, I have a for loop that's going to iterate, it would seem, n times. And this is indeed our common paradigm. Doing for I in the range of n allows us to iterate from 0 on up. And then that innermost line of code is just going to go ahead and print out some number of hashes. And recall this trick whereby we're using the multiplication operator, but really just to automatically concatenate one or more of these hashes together. So hopefully the net effect of this program, once we actually run it per these final two lines, and main is invoked and then pyramid is invoked, is that we'll get a pyramid of the corresponding height. But suppose now that I very enthusiastically went about trying to run this program, and so I went to my terminal window and ran Python of mario.py, and then I went ahead and proposed a height of 3, the goal being to have 1 hash, 2 hashes, 3 hashes, so that the total pyramid is of height 3. I'm a little disappointed already to see that it's not quite correct, this output. I seem to have a pyramid really of height 2 because there's a blank line and then a single hash and then 2 hashes. But again, what I wanted was 1 hash, then 2 hashes, then 3 hashes, forming a pyramid that's in total of height 3. Now, you might have an immediate instinct as to how to fix this problem. And indeed, relatively speaking, this isn't the most complicated program, at least if you're a few weeks into learning and writing code in Python. But suppose that it's just not obvious to me, or this is representative of an even more complicated problem down the road. And so I'd really like to start figuring out systematically how to solve this particular bug. Well, what's one tool in my toolkit? Well, let me propose first that I do this. Let me clear my terminal window to get rid of the output from before. And let me propose that it might be helpful for me to maybe figure out if maybe I is wrong, right? I is my variable in this for loop that's responsible for printing out, presumably, 1 hash, then 2 hashes, then 3 hashes, and so forth. So maybe just to check my understanding here, I should, maybe why don't I temporarily just print out I in addition to these hashes, just so that I can make sure that I is what I expect next to the appropriate number of hashes, which is to say, print itself, the function we've been using now for quite some time, is a very reasonable, effective tool for debugging, at least in some cases. It's a nice way to quickly and dirtily kind of see what's going on inside of your code. Well, let me do this. In addition to printing out that number of hashes, let me also print out the value of I. But rather than print out a new line, which I think is going to completely mess up the pyramid, let me just end the line with a single space, just to kind of push the cursor over to the right so that my pyramid is printed to the right of all of these integers. All right, let me go down to my terminal window again and run Python of mario.py, enter. I'm going to again type in 3 for the height. And now I see essentially the same output, but I've prepended, so to speak, to each line, the value of I. And now maybe it makes a little more sense to me. Now maybe the proverbial light bulb just went off over my head because, oh, the reason I'm seeing a blank line and then only 1 and only 2 hashes on the screen instead of 1, 2, and 3 respectively is because I, of course, now I remember, starts from 0. Certainly when doing a for loop like the one I have here on line 7. So how do I go about fixing this? Well, I think instinctively I could just do this. Let me go ahead and remove the previous print. Indeed, when using print to debug your code, it's usually temporary. So I should now undo that change because I don't want those numbers to appear ultimately in my program's output. Let me go ahead now and print out, OK, I don't want to print out 0 hashes and then 1 and then 2. I want to print out 1 more than the current value of I. And I bet there's a bunch of ways I can solve this, but I think the easiest way might be this. Let me go ahead and in parentheses do I plus 1 so that what I'm really doing is multiplying this single hash by I plus 1. So instead of being 0, 1, and 2 hashes respectively, now it's 1, 2, and 3. And I've parenthesized it just to make clear to myself that indeed the math is going to happen first, just like in math class, inside of the parentheses, and then I'm going to use that total value for the concatenation of all of those hashes. All right, let me go ahead now back to my terminal window, clearing it, running Python of mario.py once more. Let's again type in a height of 3, and now I have the intended pyramid. So a minor bug, if you will, certainly if you're several weeks into learning Python already, that kind of bug might have jumped out at you pretty quickly, but that's not always going to be the case. And so print is the first of your friends when it comes to debugging your code. Using print, you can temporarily, but pretty easily, just display the values of variables or other things in your program, just so you can help see what the computer sees underneath the hood, so to speak. But it turns out there's more powerful tools, and print can start to get a little tedious, especially if you're adding a print up here and up here and up here and up here and all over the place in more complicated programs, because then you have to clean up a whole mess that you've made, and you might have put the print in not the right location, and you have to remember what output is coming from one print. So eventually, print is not so much your friend, and we need better tools than that. So let me go ahead and clear my terminal window again. Let me undo these changes so that I again have the same bug, where I'm now printing out I number of hashes, so 0, 1, and 2 again. And let me propose that we use another tool that comes with a lot of programming environments nowadays, VS Code included. Indeed, typically I've hidden the so-called activity bar to the left-hand side here of VS Code, but I've revealed it today so that we can see some of the functionality that actually comes with VS Code. And other text editors and other IDEs, integrated development environments, often come with built-in debuggers. And indeed, a debugger is a special type of program whose purpose in life is to do just that, to help you debug your program. It doesn't necessarily solve the problems for you, so it's perhaps a bit of a misnomer, but it helps you, it empowers you to solve bugs yourself and eliminate them more methodically than maybe print alone would allow. So I'm going to do this first. I'm going to introduce this notion of what's called generally a breakpoint. A breakpoint is simply a mechanism when using a text editor or an IDE that allows you to specify on what line or what lines of code do you want to pause or break execution of the program, just so you can start poking around at that line of code. In other words, if I keep running mario.py in my terminal window, it pretty much runs from top to bottom, left to right, again and again, pausing, of course, for my own human input, but it's so darn fast Python that I can't really see what's happening on each individual line of code. So let me go back to VS Code and this time set a breakpoint. Wouldn't it be nice if I could pump the brakes, so to speak, and slow down the execution of my program so that I can tell the computer when I, the human, am ready to step, step, step through each of my lines of code. So it turns out that to the left of the line numbers here in VS Code, and this is a popular approach in other programs as well, notice if you hover over to the left of a line number, it becomes a grayed out form of red. And if you click on it once, it becomes really red. And what that indicates is that I've set one of these things called a breakpoint. I've indicated to VS Code in this case that I want it to break, that is, pause execution of my code just before main is called. And I can actually set it on almost any of these lines of code, but I'm starting at the very bottom one because, of course, that's the line of code that we know is going to kick off the whole process of running my code, but it's going to allow me, therefore, to step through any and all of the specific lines therein. So let's go ahead and do this. But now, I'm not going to go ahead and just run Python of Mario.py. I need to actually run the debugger. And the debugger in VS Code is pretty smart to figure out exactly what I want to run, and you can even configure it to be even more customized. I'm going to go ahead and perhaps aptly click on this icon here, aka Run and Debug, and it's the little play icon with what appears to be an actual bug on it. And when I click that, this additional panel opens up in VS Code, and its big button there is called Run and Debug. Now, I could follow more of the directions and customize it further, but I'm just going to go ahead and click Run and Debug. And using some default settings that I might have specified earlier too, it's going to run my program, but pause it on this line here. Notice that in yellow on line 12, that's where I set the breakpoint, and the yellow highlight of line 12 means that line of code has not yet executed, but it's about to be executed if and when I am ready. There's a bit of noise or messy output in my terminal window potentially, but that's just part of the debugging process. In my terminal window eventually will I see that same prompt for height. But I don't yet because I'm not at that line of code. Now let me draw your attention to all of these icons at the top of the screen. The first of these, which looks like a play button with a line to the left of it, is this continue button. If I click that button, the breakpoint is going to be left behind and my code's just going to continue on to the end of the program. That's probably not what I want in this case because I actually do want to step through it line by line. There's this next icon here, an arrow going over a single dot, that's the step over command. This would allow me to step over this line 12. It will execute it, but that's it. It's not going to step into that function so that I can go line by line through main or in turn pyramid either. The one I really want to use now is this one in the middle, step into. And this is the line pointing down at the dot, which is a symbol that indicates that if I click this button in a moment, I'm going to step into line 12. That is, I'm going to step inside of the main function. And from there, I can continue to step by step walk through my code. So watch what happens on the yellow on the screen here when I click step into like this. You'll see that now line 12 has begun executing, but when we step into that function, notice now that the debugger has broken or paused on line 2. Line 2 has not yet executed, but as soon as I step over this one, I think we're going to start to see some results. And I was careful there to say step over instead of step into. Why? Well, notice on this line of code too, there's two functions, input and int, and I didn't implement either of those. And allow me to propose line by line through main or in turn pyramid either. The one for the debugging process in my terminal window eventually will I see that same prompt for height. But I don't yet because I'm not at that line of code. Now let me draw your attention to all of these icons at the top of the screen. The first of these, which looks like that's the step over command. This would allow me to step over this line 12. It will execute it, but that's it. It's not going to step into that function so that I can go line by line through main or in turn pyramid either. The one I really want to use now is this one in the middle, step into. And this is the line pointing down at the dot, which is a symbol that indicates that if I click this button in a moment, I'm going to step into line 12. That is, I'm going to step inside of the main function, and from there I can continue to step by step walk through my code. So watch what happens on the yellow on the screen here when I click step into like this. You'll see that now line 12 has begun executing, but when we step into that function, notice now that the debugger has broken or paused on line 2. Line 2 has not yet executed, but as soon as I step over this one, I think we're going to start to see some results. And I was careful there to say step over instead of step into. Why? Well, notice on this line of code 2, there's two functions, input and int, and I didn't implement either of those. And allow me to propose that the people who invented Python probably implemented input and int correctly, so there's really no point in my stepping into their functions or even trying to. I really should only be stepping into my own functions. But I do want line 2 to execute, but let me call your attention to this. At the top left of VS Code now, there is under the Run and Debug panel some mention of variables, both locals and globals. And there's nothing under locals at the moment, because at this moment, before line 2 has been executed, no variables actually yet exist. In a moment, once I do execute this line of code and step over it, well, a variable called height should exist. So let's try that. I'm not going to click step into, I'm going to click step over, but that will not ignore the line of code. It will execute it, but not dive into it, if you will. Once I click step over, notice that the line is no longer highlighted because execution hasn't broken or paused yet. Notice in my terminal window, despite the output from earlier, I'm being prompted for the actual height of the pyramid. So this part is still interactive. Let me go ahead and type 3 and hit enter, and now we'll see what's happened at the top of the screen. Line 2 has just executed. The height variable now exists. And indeed, if you look up here, you'll see in the debugger a graphical summary of all, or in this case, the one variable that now exists. And better still, you see the value of that variable. Now, that's not that helpful at the moment because I'm pretty sure the height is a variable. That is, so let's step over this line, thereby executing it. But watch the top. It's no bricks. Oh, this is where now I might realize this is why my program is flawed, because when I equals 0, I'm apparently printing 0 bricks. Aha! Now hopefully I understand. If not, no big deal. I can continue stepping over because I know that it's flawed, sophisticated, or heck, maybe it's someone else.
Well, hello one and all, and welcome to our short on handling exceptions. Now, when things go wrong in our programs, we can handle them and hopefully correct our program as it runs. And I have here a program called distances.py that I'll admit is a little bit buggy. Now, what I hope distances.py will do is take this dictionary of distances and actually convert each of them to meters when I ask for the distance of some given spacecraft. So for instance, if I entered in Voyager 1 down here on line 11, I would hope to convert 163 here to meters and then print however many meters Voyager 1 is away from Earth. Now I use a function called convert down here, which simply takes some given number of AU, astronomical units, and converts it then to meters using this constant that converts between, in this case, AU and meters. But I don't think my problem here is with convert. I think it's up here in main. So let's go ahead and try this program out. I'll go ahead and run Python of distances.py, and here I'll try to enter in Voyager 1. And hopefully I should see the number of meters Voyager 1 is away from Earth. I'll hit enter here, and I seem to have gotten a memory error. Now, why might this be the case? Well, you might notice that Voyager 1 has a distance of 163 AU, but this in particular is written as a string, not a number. And if I were to access this value, 163, the string, and pass it into convert, well, this star syntax means something else entirely from what it means with numbers. When I take a string, let's say the string 163, and multiply it, let's say, with this star operator by whatever this huge number is, I'm essentially saying take this 163 as text and repeat it however many times this is down here, which is more than enough to kind of overflow the memory I have here in my computer, and I don't want to be doing that down below. So what should I do instead? Well, we've seen these functions to convert between, in this case, text and numbers. And you'll get messy data like this all the time. So it's our job to make sure we're getting the data we want to, using functions like these here. Well, ideally, I want to convert, let's say, this text 163 or 136 into some number. And I can use a function like float to do just that. Here, I seem only to have integers, but I can be more general and say, let's just use floats. I'll take maybe 163.2 AU in the future, for instance. So I'll take float here, and I'll maybe first pass as input the value we hoped to get from our dictionary. And I'll store that as a value called AU. And I'll then convert the value of AU to meters in this case. So to be clear, we're going to access the text Voyager 1 again, and now we'll see that Voyager 1 seems to be some very large number of meters away. So that seems to work here, but what still could go wrong? Our data, I would argue, is still pretty messy. If I look here at Pioneer 10, I see the text 80 AU, and that doesn't seem to be something that could convert to a float. In fact, let's try it. I'll type python of distances.py, and I'll type in Pioneer 10, and so here is how to convert a function. This exception here, why don't we try using this block of code called try and except block. As I said before, I can really just try to do the thing I want to do, which is convert, let's say, this distance to a float and store it, in this case, in this variable called AU. But of course, things can go wrong, as we just saw before, and we should be mindful of how we handle the exception that could occur. So if I want to make a new, let's say, handler, a way of handling this exception, I can use an except block here, and I'll type except, which is a keyword in Python, followed by the name of the exception that I think could happen. And in this case, we saw a value error. So I could, within the indented block here, try to handle this value error. Maybe instead of showing the error to the user, I could maybe instead just print something a little more friendly. I could say maybe can't convert whatever the value we had here was, distances spacecraft, to a float, just like this. And then, because we can't really convert it to a float, I'll go ahead and end my program by calling return. So let me separate this here for logic's sake and style. Here, I'm taking input and asking for that Python of style. Let me go ahead and put some single quotes around here just to do this. Pioneer 10. And now it's clear that our string was 80 AU. We couldn't convert that string to a float because, of course, it has AU for 80 error to the user. Let's try this, a float. It's clear that our string was... So this is one exception. Let's take a look at our line of code here inside of this try block. What other things do you think could go wrong with this line of code that could raise an exception? What I have in my mind is that I have here 5 spacecraft, but what if I asked for one that wasn't on this list? Would this code work or would it not? Let's try it out. I'll say python of distances.py, and maybe I'll enter in the James Webb Space Telescope, which is not part of my dictionary up above. I'll go ahead and hit enter, and now I see another exception, one called a key error, which means I can't find this value, James Webb Space Telescope, inside of my dictionary, or can't find this key, rather. So it turns out that this line of code could trigger a value error and a key error, depending on the input the user gives me. And if I want to handle those exceptions differently, I can certainly do that. Within this try and except block, I can go ahead and add a new block here to handle, in this case, the key error we see down below. So to be clear, when I put this line of code inside try, I'm kind of listening or waiting for, being ready to handle any exceptions I might come across. In this case, if those exceptions are a key error or a value error, I'll run the code indented in either of these blocks, respectively. So if it's a key error, what could we tell the user? We could probably tell them that the spacecraft is just not in the dictionary. So I'll say here, print, and maybe can't, maybe actually let's type, spacecraft, whatever you typed in, is not in dictionary, just like this. A bit of a more friendly message than the key error we saw down below. I'll similarly return saying my program is done if we can't find the spacecraft you're looking for, and let's see what happens down below. I'll type Python of distances.py. I'll then type in James Webb Space Telescope, hit enter, and we'll see that, quote unquote, James Webb Space Telescope is not in the dictionary. So here we've created two handlers for these various exceptions that could be raised, key errors and value errors. Now you could, if you wanted to, try to handle all kinds of exceptions within one block. Something like accept exception might work. But in general, it's good practice to be as specific with your exceptions as you possibly can. It's good practice as programmers to actually know what kinds of exceptions could be raised as well. In this case here, there are really two kinds of exceptions that could happen here. One, of course, was the value error, and the other was the key error. So as you write code, try to anticipate these exceptions and hopefully write some code to handle when you might encounter those exceptions instead. So this here was our short on handling exceptions. We'll see you next time. Well, hello one and all, and welcome to our short on raising exceptions. I have here a program called pace.py. Now, here in Boston, we are home to the Boston Marathon, which invites runners from all over the world to compete in one big marathon. But to qualify for it, you have to run some other marathon at a certain pace. So if you, like me, are running as a male in their 20s to 30s, you would have to run 26.2 miles in less than 180 minutes or 3 hours to qualify for the Boston Marathon here. Now the question for me, or for you all too, might be, well, how fast is that per mile? Well, I have here a function called getPace that takes in two inputs, miles and minutes, and returns to me the number of minutes per mile I would have to run to qualify for this Boston Marathon.
Hello.
So I'll go ahead and run Python of pace.py, and I'll see I would need to run each mile in 6.87 minutes to qualify for this marathon. Quite a fast clip. Now, as I've written this function, if I'm thinking like a good programmer might, I should probably think through a few things that could go wrong and how I could alert the user to them. Well, one thing that strikes me here is that there really is a certain range on the minutes that are really a valid input to this function. I wouldn't probably input a negative number of minutes, and if I input even 0 minutes, for instance, I'll run Python of pace.py, well, I'll see a pretty nonsensical answer, in fact, an impossible task. So how could I alert the user when something in my function has gone wrong or they've used it in an incorrect way? Well, of course, I could print some message to them, but now that you know about exceptions, you have one more tool in your toolkit for alerting programmers and users when things go wrong. So let's see here. Let me ask a question in getPace. I could ask the question, if it's not the case that minutes is greater than 0. In other words, if minutes is 0 or less than that, negative, we want to do something, but not return, in this case, the number of minutes per mile. Well, again, we could print something here, but let's experiment with exceptions. You've seen how to handle exceptions, but you can also raise your own using this keyword Python has called raise. So I'll type raise here, and after raise, I need to type the name of an exception that I want to raise. If you look at the Python documentation, there are many types of exceptions for different scenarios, but the most generic of them all is this one here, simply exception. I'll type the name followed by parentheses, and now if I run python of paste.py, if I give 0, this invalid input, to minutes, let's see what happens. I'll see down below that my function has raised an exception. Very generic, it's just exception, but it has in fact raised an exception. So when you're raising exceptions, it's important to be specific about what went wrong. And if I go look at this on line 8 again, well, really, this scenario is one that is fairly common. In this case, the user has given me a value that is of the right type. It is a number, but it's not in the range that I expect. So Python actually has an exception for this scenario. When a value is the right type, but not in the right range, this is actually known as a value error. So I could raise, more specifically in this case, a value error. If I run python of paste.py, I'll see not just a generic exception, but now value error to symbolize exactly what kind of error happened. Now, I could be even more specific exception for this scenario. When a value is the right type, but not in the right Python raised an exception. Very generic, it's just exception, but it has in fact raised an exception. So when you're raising exceptions, it's important to be specific about what went wrong. And if I go look at this on line 8 again, well, really, this scenario is one that is fairly common. In this case, the user has given me a value that is of the right type. It is a number, but it's not in the range that I expect. So Python actually has an exception for this scenario. When a value is the right type, but not in the right range, this is actually known as a value error. So I could raise, more specifically in this case, a value error. If I run python of paste.py, I'll see not just a generic exception, but now value error to symbolize exactly what kind of error happened. Now, I could be even more specific if I wanted to. I'll clear my terminal, and in fact, inside the parentheses, I could give a string that will be shown to the programmer or the user when this exception is raised. I could say something like invalid value for minutes. I could run python of paste.py, and now I'll see value error, invalid value for minutes. There are certain conventions for the kinds of text that should be shown when you raise exceptions. There are even different schools of thoughts. Some might say you should just tell them what the error is. Some might say something like, here's what you should change. And instead of invalid value for minutes, they could say minutes must be greater than 0, for instance. There are different schools of thoughts about how to actually raise these kinds of exceptions and the actual text to include. But for the purposes of this short here, you've now seen how to use the raise keyword, how to specify an exception, and how to provide some text to go along with it. This then was our short on raising exceptions. We'll see you next time.